So this question is called reducing holdup. We just learned that holdup was this problem where two people are working together and they're investing some amount of money to create value. And the holdup problem was where each person underinvested because they thought, well, we are splitting the value evenly, and if I just invest less, well, then I'm saving money, I'm maximizing my individual surplus. And the holdup problem is both people end up doing this because they anticipate the other guy is going to underinvest. Well, this is a little different setup. It's a very long question. You want to dissect this question, understand what it's asking, and be comfortable solving this. The end question is, what is the most Ben would be willing to pay to hire the auditor, assuming he is risk neutral? So we're going to find the value that the auditor creates. Just like in the value of information questions, we found expected profit with no information, expected profit with information. The difference between those two numbers was the most we'd be willing to pay for the information. So you can think of the auditor as information in this case. So what's the story real fast? So Ben is going to front this investment, and he thinks that Sam is for sure not going to honor the contract and pay him back half of the investment later, because they're going to split the gains evenly no matter what. But if he doesn't have this auditor, he thinks that Sam for sure is going to have the holdup problem and basically go back on his word and not hold up the contract. So that's one assumption that we're making, which is a little kind of a weird assumption to assume that people are just going to do the wrong thing, basically. But that's an assumption that we're making, so you have to understand that first. So with no auditor, with no information, we're going to have the holdup problem with 100% certainty. So the idea is Ben can hire an auditor, and the auditor will literally take records of everything that they talk about, and with these records, the auditor is going to lead to reducing holdup or killing the holdup problem 80% of the time without any trouble. Well, then 20% of the time, it's not that 20% of the time there's going to be the holdup problem with the auditor. It's that 20% of the time, Sam will think, I don't have to pay back that my half because the records aren't that good, and they'll end up going to court. When they go to court, 60% of the time, Ben still wins his case, and Sam still ends up paying back half of the initial investment. So we're going to draw a tree soon to show you exactly what's going on. But first, we're going to solve for, with no auditor, what the total surplus for Ben is going to look like. Because we're looking at this question from Ben's point of view because, after all, it said, what is the most Ben would be willing to pay to hire the auditor? So let's do that. So total surplus in the first place, it's 600 times the L&I minus I. And again, Ben is throwing down this investment by himself at first, and the contract says, or the deal they've made says, later on, Sam will repay him half of the investment. Well, with no auditor, we already said there's going to be 100% the holdup problem. So total surplus for Ben is going to look like this, where we're just dividing the value by 2, and we're leaving the investment level by itself because Ben kind of knows Sam's not going to pay him back, so it's going to lead to the holdup problem. He's going to underinvest. And we see that's going to be the 300 times the L&I minus I, and we can easily solve for I in this case to be equal to 300. So total surplus for Ben, we just plug, now this is where you want to be careful. We're going to plug it back into this equation because this is the equation that's going to tell us Ben's total surplus. We're going to split the value in half, and he's going to end up paying all of the investment. So that's literally what it's saying. You want to be really comfortable understanding why we're plugging it back into this equation instead of this equation. So again, that's because they're splitting the value evenly, and he is taking the whole investment. He is paying that whole I. So here we see the total surplus for Ben is 1,411.13. Well, real fast, let's draw this tree, and just to make it clear what we're doing. We just solve for no auditor, and we have the holdup problem for sure. Now with the auditor, the idea is 80% of the time, the records are going to be so clear that Sam's just going to honor the contract. There's not going to be the holdup problem. 20% of the time, it's not that we have the holdup problem, but we go to court because Sam thinks he has a good chance of not having to repay half of his investment. And when they go to court, 60% of the time, we still have no holdup because the court sides with Ben and makes Sam pay back half of the investment. That means 40% of the time, we do have the holdup problem. So this tree is really going to help you organize this next line, so it may be helpful for you to draw it. And again, we already said we solved for total surplus for Ben with the holdup problem to be that. So now let's take a look at with the auditor, and I wrote probabilities here because now you want to know that it's not going to be certain that we're going to have holdup or certain that we're not going to have holdup. There's some chance of each scenario. So I just wrote probabilities to help you remember that. Well, let's look at this paragraph and dissect it and write our line. It says, with these records, again, there's a probability of 0.8 that the information will be such as to clearly allow Ben to have the contract enforced by a court. So Sam knows that percentage, and instead of going to court, he'll honor the contract, is basically the story. And again, the 20% of the time, we're going to go to court, and 60% of that time, Sam will have to repay the investment. So as we start to build total surplus for Ben, we know that 80% of the time, we're going to have the whole thing divided by 2 without the holdup problem. 20% of the time, 60% of the time, we're still going to have the cooperative form of this game where we don't have the holdup problem and we're dividing the whole thing through by 2. But 20% of the time, 40% of the time, we're going to have the holdup problem. We're going to just divide the value by 2 and treat our investment by itself. Now, keep in mind, anytime we ever have probabilities, they have to add up to 100%, and they do. In this case, we have 80%, 20% times 60%, that gives us 0.12, and 0.2 times 0.4, that gives us 0.08. So when we combine like terms, we see that it is going to add up to 100%, and that's crucial. It has to add up to 100%. So 92% of the time, we're going to have no holdup. 8% of the time, we are going to have the holdup problem with an auditor. From here, we're able to pick our level of investment, knowing with confidence that we're going to be much less likely to have the holdup problem. So that was the story. Ben has way more confidence that everything's going to go smoothly. He's going to get his money back, and he's willing to invest more because of it. So we take the derivative, or we can simplify first. We take the derivative with respect to I, and I always leave the probabilities outside of the parentheses. It makes the derivative a lot nicer. But we also notice it does something else helpful. This 0.92 is going to be multiplied by that, 300 divided by I, and this 0.08 is going to be multiplied by 300 divided by I, and then we can distribute through the 0.92 to the 0.5 and the 0.08 to the -1. But we see 0.92 times the thing in parentheses plus 0.08 times the thing in parentheses is just going to give us 1, so we can get rid of that. And now start to combine like terms and solve for I. When we divide through by 0.54, we find that I is equal to 555.55 repeating, which is a lot more than that he invested, which was only 300 with holdup for sure. So we see that the auditor gave him that confidence and he was willing to invest more, knowing that he's more likely to get it back at the end. So with the auditor, when we plug in I, we're going to, now be careful, we're plugging in I into this equation, into our probability, our 92% chance of having no holdup, our 8% chance of having the holdup. We're plugging I back into that equation. And we see that we're expected to have, if we're Ben, our total surplus to be 1,595.996. So going back to our tree, we just solved for the left branch, or this with auditor branch. And that, again, that total surplus was 1,595.996. So here, again, we're just looking for the value of the auditor. We're going to subtract those two numbers. We know it's a positive answer. And just like in the value of information questions, this is how we solve for the most that Ben would be willing to pay for the auditor is the actual value that the auditor creates.